Oh, and welcome to more Nerdy Rodent Geekery. Today I'm going to be once again diving into the world of Stable Diffusion, and this time I'm going to be looking at Dreambooth. This allows you to add anything you fancy to Stable Diffusion, much in the same way as you can with Textual Inversion. In fact, the code is based on Textual Inversion, although rather than creating those lovely, tiny, very easy to share embeddings files, you'll be unfreezing the checkpoint and modifying that, thereby creating absolutely massive files, which are a lot more difficult to share. On the upside, however, the quality can be a little bit better, and it can be a bit easier to style those things that you add as well. Okay, so without further ado, let's dive into what you need to get this running locally. You will, of course, need an operating system, either Ubuntu, Linux, or Microsoft Windows is fine. So if you're using a Mac, terribly sorry, this guide is not for you. You will also need an NVIDIA GPU, one with at least 24 gig of VRAM. So if you're one of those AMD users, again, terribly sorry, not the video for you. You're also going to need Python. I use Anaconda because that makes absolutely everything terribly easy. I would suggest you use Anaconda as well. If you're an absolute beginner with using Microsoft Windows and you've never downloaded and installed things off the internet before, then don't worry, got you covered there as well. There's also a link there which shows you how to download and double click on a file and then start the program that you've just installed as well. So that video is for you if you're an absolute beginner with Microsoft Windows. Now, I'm going to be using two different things here. I'm going to be using the command lines that they show in the actual repository, but I'm also going to be using Automatic 1111's Stable Diffusion WebUI. So if you have that as well, then that's brilliant. That's brilliant. So no coding or skill is required whatsoever because I show you how to do absolutely everything. Just follow these steps. There's less than 10 of them. You can do it. So some top tips for watching this video. First thing to do is just watch it all the way through to the end, and then you'll get an idea of all the things that you need, what's going on, how you're going to get ready, and plan what you're going to do. Then you can watch it through the next time, knowing exactly what you're going to do, and pause at each different step, because some of these commands do take a few minutes to run. There's a Q&A at the end, which will make a whole lot more sense if you've actually had a go at doing this once already. Okay, so let's dive into this. Make sure you have your Anaconda prompt open now, and you can basically follow along. Okay, now if you followed my video, you'll already have Git installed for Windows. If you haven't, then conda install git will get you git. Sudo apt install on Linux will get you git as well, and then you can git clone the repository. So let's have a quick look. There it is. If you want to git clone, and then you can copy pasta that'll get you your command. Yeah, okay. So I already have this downloaded, so I'm just going to cd into that directory. Now I've put this into a GitHub directory because that's where I download all my stuff to when I download it off GitHub, but obviously that is wherever you have downloaded it to. Now you're also going to need another little script as well. Let's open this hyperlink. This is a different repository, but the only thing we need out of here is prune checkpoint. So you can just click on that, click on raw, and then select everything, copy, paste that into your favorite text editor, and then we're going to save that into the scripts directory as prune checkpoint. Great. So we've got that saved. We've got that. It's an optional script, but it does help you make your checkpoints a little bit smaller. Cuts it down from 12 gig to about 2. Great. So we've downloaded it. We've changed directory in there. We've got our extra script. Let's activate our conda environment. If you're using Stable Diffusion in a conda environment already, then you'll already have LDM, so you can just conda activate LDM. That will run. Okay. If you're not using Stable Diffusion, if you've never had it installed before, this is your very first time, or you haven't got a conda environment set up for it, then conda create -f environment.yml will do that for you. Now, this will take about 5 or 10 minutes to run, so I'm just going to modify time slightly now. Excellent, so that's got everything installed, so all we need to do now is exactly the same as if you already had your environment, and conda activate LDM. Great, there we go. Okay, now of course you're also going to need a Stable Diffusion model file, which you can download from here. It's the Hugging Face Confiz website. Now the ones you want are these Confiz ones. Now I suggest you download the 1.4 original. So download weights, that one is fine. You can also use that one, but that one's a lot bigger. So just click on download weights and then save the checkpoint file. I've already got that saved. It's about 3 gig. So there you go. You've got that downloaded. Excellent. So now we can move on to preparation. Now, before you start training, you're going to need what they call regularization images. And these are basically loads of images which help prevent everything in your class from becoming the same as your training images. Regularization images should be of the same class that you're going to train on. For example, a person or a rat or a face. So if you're putting your own face into it, then the class would be face. Now, because I like to keep everything organized, I've also made 2 new directories, one called classes for the class images. So there's classes. And then I've also made a training directory as well, which is where I put all my training images. Now, you're only going to need a few training images. So somewhere between 5 and 20 is absolutely fine. And they do mention in the repository information that if the images that are generated are highly unrealistic, which happens when you generate man or woman, then you can find a diverse set of images online and use those as regularization images instead. Or you can just tune your prompt a bit so it actually gets some decent pictures out. So here is where you need to create all those images. Now, if you're already used to running Stable Diffusion, then let's just do that. So this is the automatic 1111 one. I'm going to conda activate latent diffusion, and I'm going to change it into my Stable Diffusion WebUI, and I'm going to start up the WebUI. Oops, auto launch. There we go. Oops, I can't spell launch. Launch. There we go. So here we're just starting up automatic 1111, and we're going to generate between 200 and 1,000 images. So basically just pump your batch size up to something massive, and you want something like a photo of a face or whatever your chosen class is. That there it is. So you want to do like a photo of a face. Okay. If you just do generate, have a little look at that. You go, right, yeah, that's a photo of a face. That's good enough for me. Put your batch size up, generate all those images, and then copy them into your classes directory. Now, I have one here already. So classes, class face samples. Now, I've got 700 images in there because why not? So there you go. There's just 700 random face images. They are all like that. So that's absolutely fine. Now, if you haven't got automatic 1111's WebUI and you don't know how to generate images, then that's absolutely fine, because here in the repository, down here, usage, we're doing this bit here, preparation. So we've created our LDM, we've run it, we've downloaded the checkpoint exactly like it says here. So now we're going to be running this command here. So you can also copy pasta that in as well. So if you wanted to create 300 duck images, for example, you could just pop that in there. So this is your command. So let's just copy and paste that in. There we go. So that is, oops, I need to be in the correct directory. So there it is. It's just running the scripts, stable text to image, DTIM80A, you can change all of these. So niter is the number of images you're going to create. So I'm creating 300 images there. Scale, you can leave all of those the same. That checkpoint there, so that's the checkpoint that we just downloaded a minute ago, that Hugging Face one. So that directory is wherever you downloaded your checkpoint to. And then we got the prompt is a photo of a duck, because I'm using a duck there, whatever your class is going to be. So that's going to be face, person, man, woman, rat, whatever your chosen class is going to be, that is what you got it there. And then out directory. Now I've selected class duck samples. Now I'm actually going to stop it earlier because I don't want to generate 300 images of ducks now. You might want to watch that, but yeah, anyway, so let's just have a quick look. So there we've got some duck samples, and there's my initial image of a duck. All right, so that's brilliant. So that's how you do it. Either way, if you've got automatic 1111's one installed already, just do it using the web interface. If you haven't, then just use that command off the repository. Great. Okay, so now you've got your regularization images. Like I say, I've got them in classes there. I've got a whole load of samples. You want to run the training command. So if we pop back to the repository and have a quick look, here it is, the next section there, training. So again, you can copy pasta that, very easy to run. So it's essentially there. So you keep that the same there. Config Stable Diffusion version 1 fine tune unfrozen -- train actual resume model. That's the checkpoint we just downloaded. So again, the same one that you used there, that you downloaded there. So that's that checkpoint there. Name, that's just any name you fancy. I suggest giving it a reasonable name. Now, for example, I've called mine all sorts of things like here. So me or Rodentia. Let's just move those out a little bit. But I've also added the token that I'm going to use it. So that's face. So SKS is the default keyword, and that's a face. But you can also change the keyword. So that one's ZZQRat. So I just gave it a name that indicated what token I'd used and what class I'd used. Of course, the name is entirely up to you. So data route, that's the route to your training images. So I'm going to be using these training images here. So training, I've got a face there. So this is a face I generated using Stargan. This is just a Stargan face. So I know that this person doesn't exist because I literally just made them up a few minutes ago. So those are your training images there. I've got four. Four is absolutely fine. And then your route there, reg data route, that's the path to your regularization images. So in my case, I've got classes, class, face, sample. So I've got 700 regularization images there. Excellent. So there we go. Let's just run this now. Now I'm actually going to be running this one here. I'm going to be running this command here. So let's just copy that. As you can see, it's exactly the same as the one above, but with a few little changes. So basically, I'm giving it ZZQ face because that's what I'm using the token as, and that's the face that I'm going to be using. Setting the training route because that's where I've got my data. Training face, that's that one there. Classes, class face samples, classes, class face samples. Yeah, so that's the face I want it to look like. That's the regularization data. Log directory, I'm also logging to there. So I know exactly where it's going to go out to. My class word is face because these are all faces. That's my class. Class is face because I've got face images. I'm doing 1001 steps because of reasons. The default's about 800, as it says up here. 800 steps. That will make 2 checkpoints into that logs job name checkpoints directory. Create one at 500 steps and then another one at 800 steps. Typically, the one at 500 is okay. But note that the checkpoint files can be large. They're about 12 gig each, so you'll get about 24 gig output there. You can also change the seed. You may find that changing the seed gets you better output. So let's just quickly run this command here. We'll pop this one into here, and this will take some time to run. Now, don't worry about the massive message that scrolls up here, the same as you saw when you were creating the images earlier. That's absolutely fine. It's a warning more than an error. So as you can see here, it's loading the model. It's got my model LDM Stable Diffusion model checkpoint. This is the warning that you don't need to worry about because it is frozen. We're going to unfreeze it. So it is an expected message. Don't worry about that. Absolutely fine. Lots and lots of text. You don't need to read it. You don't even need to look at it until it's finished. So that will just carry on training now. There it is. It's doing its things. It's doing a validation sanity check, and this will start going up. You'll see a little bar, and there it is, epoch 0. It's summoning a checkpoint because it's a magical sorcerer, and that will basically just go up until your global steps reaches the number that you specified. In my case, 1001, or the default is 800. So I'm just going to leave that training because that will take about an hour. And much as I'd love to leave a little bar going up on the screen for you to watch, I'm just going to modify time slightly instead. Okay, there we go. That has finished training now. It's probably closer to about 20 minutes for that. But hey, now if we have a look in the logs directory, we can see there we've got the last dot checkpoint. We can also have a look at the training images. So if you go to images, train, pop down here to samples scaled, we can see the first lot, which was about 200, wasn't so good, but then by about 400 steps, it was actually absolutely fine. So we could have stopped it at 400, but there's 600, 800, and 1000 as well. Now is an optional time, so you can run the prune checkpoint script if you want and pass it the path to your checkpoint. So you could pass it the last one there, so checkpoints directory last, and when you run that prune, that will take a few minutes to run, and that will create a pruned version of it. So as you can see there, it's taken it down from 12 gig to about 2 gig, which is a lot better. Now, if you're using the automatic 1111 WebUI, then you can just copy that into your models directory. So if we have a quick look over here, do a new window, we'll pop over to Stable Diffusion WebUI, we've got the models, so there we go. So I've created a symbolic link to it, but there it is. So this is JQKZ face because that's what I called it in this one. Now, if you're using Linux, you can just link that in. Using Microsoft Windows, you may want to copy it in. And if you're not using any of those things and you just want to run the command like you can from the generation thing there, just copy pasta that in. We can do that as well. So there we go. So I'll just copy this. Copy. Paste. Now the not an SKS face. This one is a JQKZ face. JQKZ face. And I am actually using an ever so slightly different checkpoint. So we'll just pass it let's do that pruned one, shall we? Just to show you the pruning works. There it is, copy. Paste that one in as well. And, oops. Okay, so we just go there. Need to make sure that this is actually going to accept all of those as new lines. Otherwise it will get a bit confused. Go. Feed index steps 80. That is the checkpoint we've got there. There we go. Prompt is a photo of a JQKZ face. Now this will do the same thing as before. As you can see there, it's loading our pruned checkpoints. You get that absolutely massive message scrolling up the screen. There it is, that you can just completely ignore. And if we pop over here to the outputs directory, there we go, we're getting some more text to image samples. So this is running the DDIM sampler with 84 steps. We should get something that looks a little bit like that face. Fingers crossed, eh? There you go. There you go. Okay, so let's do exactly the same thing in the WebUI here. Let's just do Python WebUI. Just do an auto launch. Now, there is a little bit of an issue with the automatic 1111 WebUI at the moment, in that when you're switching the checkpoints, it caches quite a lot of it, and so doesn't actually switch properly. You'll get a little bit left over, and you'll get some particularly weird results. So with the automatic 1111 WebUI at the moment, as of 28th of September, it may get fixed in the future because absolutely loads of changes keep getting added onto this. So for the moment, you will need to select your Stable Diffusion checkpoint, the one that you've got, apply settings. 0 settings have changed in this particular case, but then you'll need to close it again, so Control-C, and then restart it again, and then it'll actually load your checkpoint properly. So now when we do exactly the same thing here, we can do JQKZ face, and even though we're using a different sampler, you don't have to use DDIM, you will still get that face. So now you could also style it as well, so like pencil sketch, and then you should hopefully get that same face but in a pencil sketch style. Excellent stuff. So there you go, you've added everything in there, you've done it, you've trained some things, and it's all absolutely brilliant. All right, so now onto the Q&A. All right, so I want to have more than one new thing in my Stable Diffusion model, because you're used to having all those embeddings, but you don't want to have 200 gigs worth of checkpoint files and just keep switching it all the time, especially if you have to exit from Automatic 1111's GUI each time. So can you put more than one thing? Yes. The answer is yes. Absolutely, you totally can. But you will need to remember to use different keywords each time for the one you think, the things you want to add, and you'll also need to daisy chain your runs. So if we go back up to this thing here, so when you're doing the training, so rather than selecting the actual resume as your Stable Diffusion model that you downloaded, the original one, you instead want to select your checkpoint. Yeah, so the one that you saved out in here. So you'd carry it on from there, either the last one or the pruned one. They both work. I've always used the last one because of reasons. But yeah, so if you resume from that, then it's absolutely fine. You can add as many new things in as you want. I've added 3 new things. I've daisy chained it 3 times so far, and it all seems absolutely perfect. So how do you edit those keywords? Well, it's in there. You've already seen it. It's in that personalized.py file, which is in LDM data personalized.py. So there it is, LDM data personalized.py. So it's that file you want to edit, and the thing right at the top there, the training template smallest. So I put JQKZ. So as long as you change that each time to be a different word, then you can keep adding the new things in, and you'll have loads of different things in there. So if you do that, can you use all of the words? Can you use all the things in one prompt? And the answer is no. Yes and no. Yes and no. Yes, you can use the words. No, you're not going to get the result that you want. So if you've done an SKS face and a KZJ face, if you do a photo of an SKS face and a KZ, it will sort of flip between them. There's kind of a 50% weight between the two, or you may get a hybrid if you're really lucky. So no, if you want to use all those different words that you've trained into your single checkpoint, then you're better off using inpainting. Yeah, so start off using one word, then send that to inpainting, and then use your next word to add all those extra things in. So saying that, can you mix Textual Diffusion and Dreambooth? So say you've got a load of embeddings files and you've got your custom checkpoint file. Can you use those two together? Yes, you can, but no, you won't get the result that you're expecting most of the time. Sometimes I did actually get the thing that I wanted. So, you know, I said an SKS face with a nerdy rodent token rodent in the background. And very occasionally, it did actually work. But on the flip side, you can also create some hideous hybrids. So that may be something that you're wanting to do as well. But yes, you sort of can mix them. It will load them. You may not get the results that you expect. So how do you train for longer? How do you train for shorter? Basically, you've got max steps in there. You can pass that in as the option like we did up here. So there, I changed max steps to 1,000. Why would you want to do something like that? Well, we'll show you in a minute. And what are all these other options? Are there any other options I can use other than max steps? Well, yes, there are. If you run the help command, we'll just run that down here. Make that a bit bigger because it's large. So there's the help command. As you can see, there's absolutely loads of options. So have a read through all of those because there's quite a few of them. So now what happens if it works, but all of your images look exactly like your training image? Well, welcome to overfitting. Basically, you can try adding more and more varied images and perhaps train for fewer steps. As you saw in my example, it was actually fine after 400 steps. So you could probably get away with just training it for 15 minutes, maybe 300 steps would be absolutely perfect. Or how about if everything in your class looks exactly like your training data? So you've typed in face, and rather than getting a variety of things, so if I go to this, and if I just do face now, then hopefully I won't get that face. I should get a completely different one. Excellent. And if I select face again, I should get another different face. And if I select face again, I should get another different face. Brilliant. Okay. So that's regularization kind of working, basically. So if all your faces look exactly the same when you type face, then try using more regularization images. 200 is usually okay, but by all means, bump that up to 200, 400, 600, 800, whatever. What about the opposite problem? If none of your images look even slightly like your training data, well, make sure that you use your key and class. So it needs to be JQZ and that is replaced with whatever your class is. So face, yeah. So you need to use photo of SKS face. That will make it look good. Or you can train it for a little bit longer. Now, again, you can have the same problem as with textual inversion. So you can't style the image. So maybe it's been overtrained again. So again, you can use exactly the same trick as you could before. So you can use face, your keyword and class, and then sort of, reduce the power of the face. So you can do face, and this is the JQKZ face. I can never remember these letters because they're nice and random. I have to make sure they don't exist. JQKZ face, a photo of. So there, it'll just do a random face, and then halfway through it will change it to her, and then we can do maybe in the style of Picasso. Let's see what that does. Does that do anything at all? There we go, we get a little bit. So remember, you can change this number. So if we drop that all the way down to 0.1, this is very, if you go between 0 and 1, then it will change depending on the number of steps you do. So there we go, we can see it's a little bit more like her, but if we go all the way up to 0.9, then that will make it very much not like her, and that's a completely different face. So there you can sort of control the strength of how much face do you want in there, or how much whatever it is that you've trained in there. Okay, so what about if you're a complete nerd and you've noticed that when you're training, it does 200 DDIM steps for each image, and that's far too many. That's far too many. You want to do just 50 DDIM steps each time, and then training will go a little bit faster. Well spotted. Yes, you can do that indeed. So in LDM models diffusion DPM, you can set DDIM steps equal to 50. So let's just have a quick look at that. So we've got LDM models diffusion DDPM. I'll open that with our text editor. We just do a quick search for DDIM steps. There it is. Got DDIM steps. Whoops, there's another one down there. The one that's equal to 200 is the one you want to change. Whoops. Let's make that a bit bigger. DDIM steps equals 50. There it is. So that's what I've changed. So DDIM steps equals 200 is the default there. It's line 1321. So I changed mine to DDIM steps 50. And that'll make training a little bit quicker because it doesn't go through 200 steps each time. Now, what if you've got less than 24 gig of VRAM? Well, you're sort of in luck. You're sort of in luck because there is this repository over here. Now, this is a Diffusers one. So this can use as little as 12.5 gig of RAM if you use the -8-bit Atom flag. Otherwise, it will use around 17.7 gig. So it's still quite a large amount of VRAM. It's also particularly easy to install, so you can set up your Anaconda environment exactly as before, but just add these, pip install requirements, run your accelerate exactly like you did in Textual Inversion, run your Hugging Face CLI, and then run that command. Now, that is twice as fast, and it does take a little bit less VRAM, but it also produces a diffusers.bin file. So you can't use that in Automatic 1111 unless you convert it to the checkpoint format first. But you can use it in diffusers. There is a little bit down there for inference afterwards. So if you're using that in diffusers, there you go. Of course, that also only works on Linux as well. So if you do have a Linux machine, then yeah, there you go. You can use that. And what if you're using the diffuser version of Stable Diffusion? Well, use that one instead. Use that one instead. And that about covers it for now. So don't forget that at the end of this video, there are a whole bunch of other links because people keep saying, hey, how do you do that avatar and stuff? Well, I put links at the end of the video. So yeah, you can have a click on those. Tell you what, I'll show you those links now and you can click on the one for the next thing that you want to learn about. How about that? Are you ready? Okay, so let's go and click on a link.